Hi. So in this session we will discuss about linear regression. So previously we have discussed about what is linear regression, what is cost function, what is statistic behind it, and after the pre-processing technique with the help of pandas and scikit learn. And now we are up to ready how to execute linear regression from the basic from the scratch and with the help of Python also. So in this we will understand how to implement linear regression with Python. So directly go to Jupyter Notebook, and this is our data. So for linear regression we have a row, and corresponding there will be output. Okay, so year experience and salary. So there is like example, a company having employees who have set of experience, and corresponding they have salaries. So if their experience increases, their salary also increases. So there is a linear relationship between the two, and let we understand how we learn that linear regression relationship with the help of Python. Okay, so let me import some of the libraries that we're gonna use in it. So yeah, so we have imported the set of libraries. First is pandas, numpy, and matplotlib. Panda is for data frame and processing, and numpy is for mathematics libraries. Matplotlib is for visualization. So we'll use all of this in this session. So first of all, we import the data. So as you can see, the year of experience of employee and the corresponding salary. So total are 29 30 records are there. So head, first few values we can see, first 5 values, and let me describe that some more details about the data. So dataset dot describe, press tab, automatically it will complete, or yeah, it will get completed. It takes some time. So okay, so year of experience, 30 records in both of them. Mean is 5.3, and salary is 76,000 and 3. Standard deviation of between the two. So if there is null value or not, let me check. Like for example, data set dot is null dot any, and both are false. It means we don't need to do imputation. And for label encoding, we both have numerical data, so we don't have to convert it into something else. So linear regression is simple relationship between input and output. So generally input have some floating and integer values, so we don't need to convert into label encoder, one hot encoder, get dummies into these steps. And after that scaling. So there is in this step we don't have to scale, because there is only input and output relationship. We just have to plot it and just understand how the linear relationship between the input and output. So for that also we don't have to do. What we do here, we have to import some set of libraries for linear regression from scikit learn. So we do Okay, so we have imported linear regression from sklearn.linear model, and we will gonna use it. And first of all, we will uh, categorize into X train and X test. Okay, if you can just see X, so this is the values of X, and this is the Y. When we use values, that particular data frame get converted into numpy array. So if you just use type to see the type of that particular column, it will give numpy.nd array. Okay, so most of people, they for fitting of the data, for training the data, this numpy array is quite sufficient or efficient, you can say. For training the data is quite fast as compared to data frame. That's why mostly people use a numpy array for training data. Okay, so just a minute. So as you can see, we are importing, and we are taking some object of linear regression in LR in this variable. And if we check that these are the set of parameters, you can just see and check out. And for our purpose, we'll use just import it, and we will try to fit the data. And for the learning purpose, we just have to fit the data so that the parameters that we have discussed in previous video, it got trained, and after fitting in the data, that parameter will get calculated, and we get hypothesis value. Okay, so everything is internally working, and that is part of mathematics. Is totally, you cannot see, you just have to fit the data and good to go. So just fit it. And yes, for fitting we need X and Y. Okay, yeah, so here it is giving the error of expected 2D array. So inside we need to have the input should be in 2D array. So for that you need to put reshape -1, 1. When you do it, it fit the data. Okay, so after that, predict. Okay, so if we just value of predict, so it have some set of value corresponding to input. So first it get trained, and after that it give you some prediction value. So if you give in it some any kind of value, it will correspondingly give some output. Okay, so let me plot the data how it generally look with the help of matplotlib. So here, as you can see, that we have plot the data for previously we have our input data as x and output y. So we have plotted scatter plot here. So this is distribution of y salary as compared to experience. So the person who have experience of very less than 2 will have lesser salary, and the person who have greater experience salary will increase accordingly. So after that, plotting the data with respect to x with prediction value. So this is the straight line made by the prediction value. So it is straight line fitting all this data. So accurately it is predicted some of the values, that this one, this one, this one, so far accurately. And this label in matplotlib, and this is grid, that if we don't use grid, it won't print this grid, which is you can see in this graph and after PLT show. So if you want to predict some new data, so let we see that 121872. So if you want to study that, let's see, the person have of like 15 years of experience, then what will be its output? Okay, so let we use so for that we need to pass some 2D array. So we use this, it's a 2D array, and we just pass here 15. Okay, so let's see what output it will give. So output is giving is 167541. It means 1,67,541. So this amount of salary that person will have if he have experience of 15,000. Okay, so it is quite good, because if you look x, if you look here, if person have experience of 10, then he have a salary of about 1,20,000. So person who have experience of 15, he may get about 1,67,000 of salary. Okay, so that's it. So linear regression is quite very easy if we use directly Python. So that's all. And there is one thing that I want to cover, that our data is very much small. So if there is data is very large, so we can also convert that data into split, that is x train and x test. For that, how we can do that? We use sklearn library called model selection. Okay, so now here we have in sklearn.model selection module, we have train test split. This is a method generally, so it is not class. Generally underscore for class, we have a camel case of value. For example, if we have like linear regression above, here linear regression, so you can see there's a camel case, L capital, R capital. So this is a class generally. If they have underscore test, this is a method. Okay, so the method of function. So we use train test split function, and xy, and test size is 0.33. It means that our test size is only 33%, and a training size is 67%. and random state is 42. You can use anything, 0 or 42, whatever, but if I use 0, if you use 0, you'll both get the same output, same training, and the testing is just like shuffling. It's like giving a random state of output. So so if we give anything value 42, 30, so there is nothing that shuffling of data will occur. So x train, x test we have. So let's see how much data we have in x train. So total length, if I check for x train, it's 20. Okay, so total we have here 30. So now x train, similarly y train have 20, and x test will be 10. Okay, x test will be 10. Okay, so this is that. Now we can train the data with the help of I use model. So here if I fit it, it will fit the model, and mostly we need to do this type of scenario, because if you have a data, you need to check that how much accurate your data is, and for that you need to test split the data into x train and x test, and after that just predict the value. So if you check, it will give you this output. This output is only corresponding to x test. So the one thing that is very quite useful here is it got trained into x train, but it will predict the output which it doesn't yet have saw, okay, while training. In previous case, it was trained on x, and I was predicting here, just say I was predicting this on the same value of x. Okay, so it already have been trained on x, and I am predicting on the same value of x. So that's why it was far more accurate. But here I am training on x train, but it not have saw the new values. So here is predicting x test. So now we can generalize how much accurate our model is based upon the output of x test. Okay, so now we will plot the same thing here. Copy and paste, but we change it to test. This is the y test, which is the accurate value. This is the test, and this is the predicted value. Okay, let's see. So here is the output. So this is the value that need to be predicted, and this is the actual value, and this is the predicted output. So as you can see, this point, and this one far more, and this one is accurately have been predicted by linear regression. So that's it all about linear regression. You can use that same thing to implement your simple approach for linear regression. And linear regression is not like it's very simple, others, that's why many people not using it. No, such type this is not all about. So many companies, they use linear regression to solve their day-to-day problems, like for example weather forecasting, stock monitoring, everything linear regression people they use. So there's also the quite complex regression algorithm, but it doesn't matter that if you are using complex algorithm, you will have more accuracy. That doesn't matter, that depend upon the business to business where you are implementing the algorithm. So that's all about linear regression. So in the next tutorial you will understand some other algorithm or regression or so stay tuned, and please share this video to the people who you want to be. Okay, thank you so much.